Okay, I'd like to walk through how to use Newton's second law of motion to solve a simple force problem. First, this equation is made up of three simple parts. Sigma F, that stands for net force, or the sum of all forces. That's measured in newtons. M, of course, is mass, and the standard is to measure that in kilograms. The A is for acceleration. The unit for that, meters per second squared. So what this tells us is, if I have some net force, some force that is not zero, then an object will accelerate. And that acceleration will depend on how much force and how much mass. So let's think of a simple scenario. Imagine I have Bernie the block on wheels. And we come along and we push Bernie the block. Well, if we push him with some force, let's say our applied force is 100 newtons. And let's say Bernie has a mass of 10 kilograms. Question is, how much does Bernie accelerate? Well, this is obviously a pretty easy question to answer, but I want to show you how to set up problems like this in general. Grab another color. First step when solving a physics problem with forces is to draw a force diagram. So, acting on the box, we have an applied force pushing it to the right. But there are other forces that I can't ignore. There's always the force of gravity acting on the object, and gravity always acts straight down. But the block is not falling into the earth. There is a supportive force from beneath, and that's called the normal force. We could draw the normal force from where the ground is holding it up. So I have three forces acting on this block. I have a normal force acting upward, gravity acting down, applied force acting to the right. Now in this case, there's only one force up and one force down, and they necessarily will equal each other because it is not accelerating up or down. And I have one force acting in the x direction to the right. So I will say the sum of all forces equal mass times acceleration. The only force that is not canceled here is the applied force. So 100 newtons. The mass is 10. So my acceleration is 10 meters per second squared. Now, that's very simple. What if I had a scenario in which there is an additional force? What if I took the wheels off Bernie the block, and there was some friction acting? Once again, I have some applied force acting to the right as we push the block. We still have gravity acting down. We still have a normal force acting up. But now I'm going to add a new force. I'm going to say that there's friction with the ground. The box rubs against the ground, and that force of friction is there. Now later in the unit we'll learn to calculate how much friction there is based on mass, roughness of the ground, and so on. For now, let's just say that the applied force pushing Bernie the block is again 100 newtons. But now we have friction. Let's say there are 40 newtons of friction pushing back. Now, net force equals MA. My net force is going to involve an applied force to the right and a frictional force to the left. So I'm going to call right forces positive, left forces negative. So applied force minus friction equals MA. Now I've written my Newton's second law equation, I just substitute in what I know. The applied force is 100. Friction, we've been told, is 40. The block is still 10 kilograms. And so we have an acceleration of, not surprisingly, less acceleration this time, 6 meters per second squared. So, when we solve a physics problem like this, we draw out our diagram, draw in the forces in the proper directions, and then solve for what's unknown. In the coming videos, we're going to see what happens when the applied force happens at angles, and when we have unknown friction, and when the block is on a ramp.